Hello guys, it's class time again. Welcome to Valeto's Maths Academy. Today we'll be looking at swords, like I promised. Okay, the aim of this class is to understand what swords are. In in some lessons before, I told you guys we're going to take a deeper look at swords and factorization. So here we are. We'll also be checking how to simplify swords using rules of square roots. Then we'll add, subtract, multiply, and rationalize swords. Then we'll practice using worked examples and interactive tasks. Okay. So we say a sword is an irrational root that cannot be simplified to remove the square root or cube root or fourth root, whatever it is. An example of a sword is root 2, root 3. This cannot be simplified further. But note that things like root 16 is not a sword, because this can be simplified. The square root of 16 is 4. Root 4 is not a sword. Is because the square root of 4 is equal to 2. So it's a rational number, it's not a sword. Once it can be simplified into a rational number, you cannot call it a sword. Swords are used to express exact values. We move on. We'll look at an example. Simplify root 18. If we're to do this, there are certain rules of square roots. For instance, root 18 is the same thing as root 18. Sorry, what are the factors of 18? 9 and 2. So root 18 is the same thing as root 9 times 2. Yep. And this is the same thing as the square root of 9 times the square root of 2. You should put this in mind. Then here we can simplify it further to know that the square root of 9 is equal to 3 root 2. Okay, that's how we arrived here. So root 18 can be simplified to 3 root 2. And also note that another rule of square roots is the square root of a times the square root of a is equals to a. If you followed us in our indices class, you should understand what we are talking about. So if you have not seen our classes on indices and logarithms, please help yourself by going back to go through those classes, as it will help you here. All right. So note that the square root of a times the square root of a is equals to a. And also remember that a square, okay, there's no need for this. All right, we'll move on. Let's not make it too complex now. Okay, just take a look at our classes on indices and logarithms. All right, we'll look at another example. 2 root 3 plus 4 root 3. Here, sorts are so simple. In fact, mathematics in general is as simple as it gets. Yeah. Here, all you need is to look for the like terms. What are the like terms here? In this expression, we have root 3. In this expression, we have root 3. So root 3 can match. Is our like term here. So all we need to do is to add the coefficient of root 3 here and the coefficient of root 3, which is what? 6, by this plus sign. So this is the same thing as we bring out what is common root 3. Yeah, 6 root 3. Okay. Rationalize 5 over root 2. You know, 5 over root 2 is not a rational expression. It's irrational. So what by rationalize, we want to make it an expression where either the root sign is the numerator and the denominator is a rational number, then it will be a rationalized fraction. Okay, so what we can do here is to multiply the top and the bottom, the numerator and the denominator, by what? The denominator, because we're trying to eliminate this. So multiply by root 2, which is the denominator. You'll say 5 times root 2 all over root 2. Root 2 times root 2 will be equal to 2. Remember that square root of a times square root of a is equals to a. Please go back to indices and logarithms in our classes here. Search for our lectures on indices, logarithms, to get a better understanding of how we arrive at this. Okay, then here we have 5 root 2. Now this is a rational expression, so our answer now is 5 root 2 all over 2. Okay, that's solved for you. I've put here a lot of practice questions that you can lay your hands on. Try to solve as many as you can. Anyone that is proving difficult for you, please let us know in the comment section and we can look at it together. In our usual fashion, we'll attempt some with you and leave you to lay your hands on the rest. Okay, so question 1, simplify root 50. You remember, like we said in the examples, the first thing we'll do, root 50 now. The first thing we do is to find the factors of 50, which are what? 25 and 5. No, 25 and 2. 25 times 2 is 50. So we can say root 50 is equals to root 25 times 2. And this is the same thing as the square root of 25 times root 2. We know what root 25 is. It is 5. 5 times 5 is 25. So we say 5 root 2. We leave our answers like this, okay? Because root 2 is a surd. Cannot be simplified further. Then we can take a look at the next question, number 2. Add 3 root 2 plus 2 root 2. Here we pick like terms, Here we pick the like terms, question number 2. 3 root 2 plus 2 root 2. What is like terms here? Root 2. We bring it out. We add the coefficients of root 2. 2 plus 3. Applying this symbol here. 2 plus 3 is what? 5. So this is something as 5 root 2. Okay. We can look at the third one. 5 root 3 minus root 3. We pick out the like terms here also to be root 3. Then 5 minus the coefficient of root 3, which is 1. 5 minus 1 is 4. So we can say 4 root 3. Okay. So please solve the remaining questions. Don't get confused. They are very, very easy. This number 4, I like it so much. I would like to see what you do with number 4. And let me know if you get it. The answer to number 4, by looking at this, should be 6. So if you arrive at 6, let me know. Make your attempts and let me see what you have. Okay. We have our interactive task. Here, it's a true or false question. Is root 16 a surd? Yes or no? True or false? Okay. Number 2, I want you to fill the blank in this expression. root 75. So what are the factors of 75, 25, and you let me know, okay? Number 3, match the expressions with their simplified form. A is equal to what? Is it 1, 2, or 3? Remember that at any time you can pause this lecture, pause the video, copy the questions, and solve at your own pace. Okay? Number 4, which is the correct rationalized form of 3 root 5? Yeah, this is an irrationalized fraction. So all they're asking you to do is to put it in a rational form. Okay, we can just look at this together. If you want to put this in a rational form, like I told you, you multiply the numerator and the denominator by the denominator, which is the same thing as 3 over root 5. Multiply this by root 5 and this by root 5. So in the rule of roots, root 5 times root 5 is 5. So this is now 3 root 5 over what? 5. Do we have anything like that there? 3 root 5 over 5. 3 root 5 over 5. Okay, that is this. Okay, so all I expect you to do is to come to the comment section and say A is my answer. Okay, 3 root 5 over 5. This is the rationalized form of this question. All right. Evaluate and simplify root 3 times root 27. This is a surd, so you can simplify this. This is not a surd. 27 is the same thing as 9 times 3. So take it from there and give me your answer. Okay. So today what we have been able to look at in this class is to understand that surds are roots that cannot be simplified into rational numbers. They follow special rules when simplifying, adding, multiplying, and rationalizing. Then I've also made you understand that recognizing patterns and square factors is key to mastering surds. Okay, we made it. This is the end of the lecture. See you in our next lecture. Thank you.